Good morning, I'm Nicola Manzella from the University of Milano Bicocca. I'm presenting to you development of joint work done with Argentina, focused on upper secondary school track choice in Italy, with an attention on the role of the school and their actors in educational paths at the tertiary phase. So we investigated analyzing the information provided to families by teachers when formulating advice towards different tracks of upper secondary schools. We connected to recent research on teachers' involuntary discrimination and related biases. We already showed a casual estimate of the magnitude of teachers' biases in according to student social origins. This paper aims to fill a literature gap regarding the explication of the discrimination that affect teachers' advices and investigating what extent teachers' characteristics explain the tertiary effects on these biases. Several promising studies show how teacher attitudes, expectations and behaviors vary towards pupils with different social origins, gender and migratory background. In example, regarding the feedback provided by teachers to their students and their families. In the 8th grade, the guidance advice seems to be formulated unequally, also in Italy, according both to the qualitative and quantitative research. Casual support for this comes from more recent analysis based on Vignet studies, as shown by Bombini and colleagues, and our work in the last year. But the question is, what influenced the advice, what influenced the formulation of this advice on upper secondary school choice? Recently, Calan and colleagues correlated teacher bias in track advice with their implicit stereotypes, but only related to the stereotypes about immigrants. So it's so interesting and useful to explore factors underlying the tertiary effects, and what about the other teacher characteristics, characteristics that can explain this bias. So moving from the volontaria alla scelta project, we consider in this paper two steps of the research and the data collected in these phases for answer to the research question. Firstly, we consider teacher level data about their characteristics collected with a factorial survey to 2,609 teachers of lower secondary schools in Italy in 196 self-selected schools. Then, after the formulation of guidance and advice, we link to administrative data from another student in INVALSI about the students of this teacher in the 3rd class, in the 8th grade class of this school. So, we consider at teacher level, in order to explore which characteristics can explicate their biases, the different data. The social demographic, gender of teacher or the age as a proxy of the experience in the school maybe, or the geographical area where are the school in which they teach and they work. Then the information about the educational path, their educational path, as the type of track of upper secondary school that they attended, or satisfaction about this upper secondary school that they are attending. Moreover, we have educational level achieved and their graduation grade. About professional training, we ask if they have completed a specific training about school guidance in the past, and about professional skill. We consider a specific role for guidance as guidance coordinator or similar, and their evaluation about guidance self-efficacy through an ad hoc scale administering the survey. So these are the variables considered in the analysis in order to explore where they affect the magnitude of the bias in the advice. Okay. The variable used to merge this data with the student level data, so to merge the teacher level data with the student level data, is the specific class section. In fact, we asked two teachers in which section of the 8th grade classes they teach in order to be able to link to their student. It should be noted that at the moment we have conducted the analysis only on literature teacher, as they are the largest sample and which allowed us to lose fewer classes and students. So at the student level, the administrative data provided by INVALSI and anagrave student of MIM allow us to control the biases related to the advice given by teacher for many characteristics of students, socio-demograph, so as gender, age, migratory background, etc., or by their socio-economic or cultural backgrounds, as cultural and economic capital of their parents, for example, the SCS of the student, etc. Then describe their social origins. Today we focus on social origins, examining how teachers' bias on students' social background vary in the magnitude depending on different teacher characteristics. Controlling by performance of the student, so the final grade in the lower secondary, and the scoring INVALSI in different tests. We measure two types of bias in a simulation context with factorial survey, in which we present vignette to teacher about a hypothetical student and ask them to formulate a simulated advice. We collect, in fact, 2,060 questionnaire with simulated guidance, advice, and information about the characteristic of this respondent teacher. And in the real world, we have data of guidance advice received about almost 11,089 students that we link to their literature teacher and their literature teacher and their characteristics, the teacher characteristics through the class section. So we estimate the influence of teachers' characteristics another time on advice bias, controlling by student performance and INVALSI score, focusing on the interaction between SCS of the student and teacher characteristics. So about the this is wrong. About the vignette methodology, consisting between subject factorial survey experiment, subfactorial survey, with one by vignette randomly composed and randomly assigned to each respondent and teacher. The vignette is composed by 4 rotating factors. It describes student descriptive characteristics as gender, migratory background, and social origin, described by stereotypical parental occupation, as we see soon, and the explicitation of student interest towards subject, so a humanistic or a STEM subject. We know about previous evidence that inequalities reproduction is played more on uncertain cases. So student performance don't vary with other factors, but is kept constant at the medium level to describe a bias, checking the performance influence. Social origins of the student expressed by the typical work of mother and father, and is explicit by Freelever, that recalls stereotypical parental occupation. In order to formulate an advice for this hypothetical student, we ask to teacher an estimated probabilities associated with each upper secondary track. Okay, let's move on. The results of the vignette we will see on the x-axis the social origin of the student indicator, in this case the parental social class, and on the y the predicted probabilities by the model of receiving guidance toward the Lyceum track. We already showed that our teacher formulated biases advice influenced by social origin of the student. In fact, students by service class have more or less 20 points higher probabilities of receive a Lyceum advice than the working class students. Okay, but if in the simulated context we don't detect a significant influence on the bias of teacher characteristic, as shown in this graph, and their gender, about the gender, age class, upper secondary track attended by the teacher, past training on guidance topic, don't have an influence in the bias. But if we move on the real world guidance advice, we see we find a bias according to the social origins of the student. Here is expressed by the SHS of the student. In fact, looking at the SHS, we see that the model predicts probabilities to receive a Lyceum advice is more than 30% points higher for the student with higher level of SHS than the lower ones. So, trying to explain this effect, we found that the gender of the teachers influence the bias. In fact, it seems that male teachers are more biased than their female colleagues, as shown the slope, the higher slope of the curve. And if you look at the gender of student that is receiving advice, we find that male teachers are not only more biased, they are even more biased with the male students. In fact, these male students see the greatest difference in Lyceum advice between those who have lower and higher levels in SHS. Regarding the age of teacher, there is a significant tendency for those in the intermediate age group, the 45 and 50 age range, to exhibit the more pronounced bias, whereas both the youngest and the older teachers, the eldest teachers, show more modest level of bias. Contrary to our expectation, we did not find significant differences based on the type of secondary school attended by the teacher. This may be because most literature teachers attended gymnasium, track, or the scientific lyceum here. We didn't find a significant difference among those who have done a professional training on guidance topics in the past. Or those who hold a specific role related to guidance in the school. And there are not even difference in bias based on the level of guidance self-efficacy perceived by the teachers. So in conclusion, in the simulation context, teacher bias seems to be influenced by, not influenced by teachers' characteristics. In the real world, we don't detect a different results except to the influence of teachers' gender and the age class of the teachers. In fact, male teachers are more biased than their colleagues, in particular with male students. And teacher bias seems to be correct due to specific age class. We explore a lot teacher characteristics, but don't explain the tertiary effect yet. But I think we can't forget that guidance advice is an extreme synthesis of a decision-making process that takes place collectively in the teacher class council. In fact, I think it's important to repeat the analysis with a larger sample in integrating teacher of different subjects, for example, math teacher or foreign languages teacher or guidance specialist. And so this is a preliminary result. Thank you very much.